AT&T ThreatTraq for March 18th, 2014. This program provides network security highlights, discussion, and countermeasures for cyber threats. I'm joined today by John Hogoboom. I'm Brian Rexroad, and John, let's get right into it. I guess, we've been talking a lot about reflection attacks and, the potential for other things. This one surprised me. So what can you tell us?
Yeah, thanks, Brian. So, right, we have been talking about reflection attacks a lot lately, but mostly with UDP protocols like DNS amplification, lately the NTP reflection. So with UDP, it's really easy to spoof a source IP and reflect it towards somebody that you want to attack. This one was an interesting one. This was a story that was covered last week. SecuriNet, their blog, they had an article about this, as well as some other people as well, but I think they're one of the first people to kind of uncover this. And this is a particular DDoS attack using WordPress's Pingback functionality. So if you're not familiar with what Pingback is, because I wasn't, I kind of was aware of it, but I wasn't really up to speed on how it works. But here's a basic kind of example of how Pingback works, and it's basically for when you're on a WordPress site, which is a blog. It allows people who refer to other people's articles on other blogs to kind of link with each other, to let them know that I mentioned your story on my blog, and to basically ping it back. So to give an example here, here's Site A on the left-hand side, and this person writing about an article here, and maybe she has some thoughts or insights about it. She references that, I read this great article, and maybe she has some extra additions to it, but she links that article in her article. So then what the WordPress site, the WordPress engine does, is it makes a XML RPC pingback request over to Site B, which is the link that she had provided in her article. And it basically says, I just posted a new article, and it says here http://siteA.com/article1, that's her article, and I referred to your article. So Site B gets this request that says there's a pingback being performed. And what he does is he makes a request back to that original article to make sure that it exists, and if so, then he adds it to his comment feeds, kind of like as part of his article that somebody had mentioned it. And so there is this kind of check back thing that happens here. So Site B makes a request back to the original source, or the purported source, and we're going to get back to that in a second here, in order to make sure that it actually is a real article and it exists, so that he will, represent it on his website. So that's the basic function of how pingbacks work. So what I guess somebody figured out that, hey, what we could do here is use this as a reflection mechanism. So an attacker up in our left-hand corner here is making XML RPC pingback requests, saying that he is at siteA.com, which he's not really. This is who the intended victim is here in his example. And he puts a question mark with a couple of random digits in here so that it makes it so it can't be cached very well in any of the entities along the way, so that it makes the website do more work. And he sends these requests to a whole list of lots of WordPress sites, and about 160,000 were reported used. So if he can make these requests to 160,000 different WordPress sites, each website gets the pingback request, and what they do is they all will simultaneously, assuming you send all these requests very close together, will try to make a request back to Site A saying, does this link exist that you just posted to me? So basically the attacker is fraudulently saying that I'm making I posted an article and he really didn't, and it's making all of these WordPress sites simultaneously try to make a check back to Site A. So in doing so, it can saturate the link for this one website and slow it down significantly. So that's the basic gist of how this attack works. What they're kind of recommending is this is kind of how it's intended to work, unfortunately. So I don't know that there's going to be a lot of changes in how the pingback protocol works, but it's interesting that it's a TCP protocol, and you can kind of almost proxy or relay in order to reflect this type of traffic. And there are some recommendations on some of the article that I mentioned here in the slides talks about ways to disable your XML RPC, but that might break your pingback functionality. So if you actually use that with your website, it might break that. And I think there might be some other ways that they're looking into to kind of mitigate the chance of this being abused. Certainly you could look for any kind of outbound link exists requests with these weird patterns like this, but the attacker will probably change their methods and use different patterns instead of just random numbers equals numbers in the future in order to get around any kind of blocking mechanism that you do.
Yeah, this is a tricky one. I guess, there are a couple of things that sort of come to mind here. One is that, I guess on the plus side, and it's always kind of good to look at the plus side of things like this, at least it's making TCP connections, so that you at least have a little better avenue of tracing it back to the originating source than perhaps you had previously. It still takes some additional footwork to be able to do it, but in comparison to the UDP-based attacks where you have spoof source addresses involved, at least in this case, the addresses are associated with real sites, and you might be able to trace it back. I guess it would get pretty complicated because I guess in many places there are lots of WordPress sites hosted on the same IP address. Still, could be a pretty tricky process to do that. It certainly looks more complex than the typical reflection attacks that we've been talking about, not just in the execution of it, but in being able to actually facilitate, get some real benefit from that attack. Would you agree?
Yeah, I would think so. I don't think I saw in the article or any mention of any kind of amplification. So we know with DNS and NTP, you can make very small requests that have very large responses. Mm-hmm. I'm not quite sure what the amplification factor is on this, if there is any. There probably is some of it, but I'm not quite sure how large it is, if at all. So in that respect, it might not be that great. Like you said, you should be able to, in theory, perhaps backtrack to even the attacker, I would think, although he could still obfuscate how he's coming through by going through proxies and whatnot. But it's an interesting tactic. There's probably, I would venture to guess, other services similar to this on heavily deployed other sites that could also be abused in similar manners. But I hadn't seen this before, and it's an interesting tactic. I did notice that when you go to the WordPress bug tracking website, this has been kind of talked about in and out for maybe about 7 years. So it's kind of been known. Initially, they had mentioned that you could DDoS like one of the WordPress sites. To kind of back up a little bit to this picture, one of the things that they had mentioned as a potential, and this has actually been fixed, is to make a request or a pingback saying that I'm at whatever/article1, but whatever is actually there is a very, very large file, and then make lots of pingback requests for it. And basically what that does makes Site B pull very large responses back as part of its check mechanism. Mm-hmm. And they've actually patched that within the past year or so in WordPress so that it limits, you can only pull back, a certain size response back from the original source website.
Like you said, this is something that we haven't been seeing so far. There certainly is a claim here that there was a significant denial of service attack launched using this method. So we'll need to keep an eye out for this and see if it's something that's going to start to manifest as a problem, or if this is kind of an anomaly in the grand scheme of things. So thanks for sharing that. It's obviously something we need to pay attention to here.
Sure.
Next item here, what I'm going to do is share with you. We've been talking a lot about devices that get compromised and the concerns around that, vulnerabilities that might allow bypass of router devices, home router devices. That's getting some additional attention or some renewed attention. And, as we've been reporting, and I think we're going to report again here a little later on in the Internet Weather Report, we continue to see these compromised devices. What I'm sharing with you here is simply an article that was recently published on the Fox News website. And I want to first point out that, they're talking about, hackers now targeting your router. I want to first point out that this is not a criticism of the article itself and the author. I think it really is, I wanted to share this with you because I think it exemplifies the type of challenge that exists to try to provide advice to end users on how to protect themselves from these sorts of attacks. That is, the diversity of different types of devices and the processes and the fact that there isn't really a good patching process around a lot of these devices is really a challenge, one that really we need to try to address going forward as an industry and improve the opportunity to be able to update these devices. So I'm just going to read from the article a little bit here, and it gets to this point where, let's protect your router. There are 3 simple steps. Step 1, you need to do a geeky thing called updating the firmware. Every router makes a process a little bit different, but here's the basic outline. First, find your router's program on your computer. Boy, that sounds, what program?
That's pretty vague.
Fire it up and it should automatically find your device. Now, I tell you what, I've had a lot of home routers. I've never had one that actually had software associated with it, or if it did, I got to admit, I never installed it. So there is an alternative here. If you don't have a router program, look up your router's manual online and see what the device's IP address is. It might tell you. Actually, the device address could be reassigned, and so oftentimes it's 192.168.0.1 or something along those lines, but which is a local non-routable IP address in effect. But again, you might get somewhere doing that, and you also might not. In case you need it, I have instructions on how to find the manual. Okay, so they actually provide a link to go and find manuals for your device. Actually, I suspect that a lot of folks don't even know what the device is. So, and in fact, I know that some devices that I have, in order to figure out what model device you have, you actually have to do things like count the antennas on the back. You can't even do it by model number. They have multiple multiple devices, different versions with the same model number, if you can imagine that. So that's just another thing. I could continue on here, but if you're interested in looking at this article, I think it's you may find it actually helpful, but again, it kind of exemplifies the challenge in helping folks update their devices. One thing I want to point out that's, I think, perhaps significant, in fact, this article sort of points out the notion of cable modems or DSL modems. Most modern devices, residential gateways, if you happen to be an AT&T U-verse customer, for example, and I know that a lot of cable providers today, most of those devices are actually managed by the provider and updates pushed out to those. So that's not really the focus of the particular devices here. What I'm really referring to are the ones where you go out to the store so that you can have, a Wi-Fi network or additional Wi-Fi networks in your home and plug it into your home network and use it. So just some, I think, a little anecdotal type article for us here. Next item here, to get back a little bit on a sort of a different twist here. We always are referring to different phishing campaigns. This one has a little bit of a different twist, doesn't it, John?
Yeah, thanks, Brian. So there's a recent phishing campaign or scam that we've been made aware of, and the guys at Symantec actually posted an article about this. And this one's interesting because a lot of the phishing campaigns that we've seen in the past, they'll target, a certain banking company or whatever, but when you look at the URL, it's usually really fishy looking. It'll be something slash, such and such bank company slash login, HTML or something like that. So it's pretty obvious if you inspect the URL that something doesn't look right here. So this campaign's a little different in that it's actually targeting Google using Google's infrastructure. So what somebody did here is they, on their Google Drive account, which is kind of like a cloud disk sharing, so you can post, put files up there and share it with the world and whatnot. Mm-hmm. So on their Google Drive account, they had posted a phishing page that looks like the Google login page. So when they fished that out to people and they said, and basically the context of the phish email that came to people said something like documents, and that they should check out this important document on Google Docs. Well, the interesting thing about this is the web page, the URL actually went to Google, and it was SSL encrypted as being from Google because it's actually up on the Google Drive web server or web servers. And a user who sees that might say, oh, I got to log in order to see this document, and they, type their login ID and password in. Well, this fake fish page that was up there, the login page for Google Docs, once it got that, it actually took the credentials, sent them to a third website, a compromised web server somewhere far removed from Google, to store that, and then that redirected you back to just another Google page, like a Google Docs page. So you might not even be aware of the fact that you typed your login, you might thought you just typed it in wrong or something, and you might not be aware that you were phished as part of this campaign. So a pretty clever tactic that they actually used Google's infrastructure in order to phish users, and is very convincing looking phish.
Yeah. Now I suspect that Google's right on top of this, and they're going to try to prevent this type of thing from happening again. But I think it really is a perfect example of the the subversiveness or the resourcefulness or creativity associated with some of these attack activities. I don't think I would have thought of this in a million years, but certainly somebody thought of it, and it really comes off as a pretty convincing situation. All right, so let's go ahead and take a look at the internet weather for the week here, and we'll start out with the same activity that we've been referring to or talking about for the last couple weeks here. This is scan sources and probes, so it's both the number of IP addresses as well as the number of probes that are taking place on port 5000 TCP. I'm showing 60 days of activity here, and the intent here of typically we show 30 days. The intent here of showing 60 days is to really sort of point out the distinction between the activity that we're seeing now compared to what we've seen in the past. And there was really virtually no activity up until about, I guess it was the second week in February here. We saw a spike in activity, and we see this typical trail off of activity, which is basically an indicator that a single command was given to the devices, to the botnet, to scan on this particular port, and as they are completing that process, fewer and fewer devices are continuing that scanning activity, and then the botnet operator renews that command, gives it a little sawtooth effect, and that activity continues. It looked like the operator took a couple of days off and reverted, or basically came back on, it looks like on the 15th of March or so, and that's continuing to tail off as we speak here today. So this activity is continuing. There is sort of a smaller level of activity that may be an indicator that somebody kind of fixed a systemic problem somewhere. It's also a possibility that the botnet operator has siphoned off or separated or split the botnet into parts. That's not unusual for them to use a portion of the botnet for recruiting activities and then other portions of the botnet for other sorts of nefarious activities, and perhaps even to rent them out or lease them out for other functions. So that decrease in activity is not necessarily a indicator that the problem is being solved by any means. As we've talked about before, the application that they appear to be targeting here predominantly is the Synology Visitation Manager, and we still are continuing to see the predominant probes from sources in China and the United States. I should point out that the probing algorithm itself, that is the way they sequence across IP addresses, is somewhat localized. So they'll be very aggressive at scanning the class C or /24 address space before continuing on to another address. And that does create a little bit of a bias in terms of what you might see in the activity that's taking place on a regular basis.
And we had talked about this before, but I don't know if you mentioned it just now. This activity seems to be originating from devices that are these embedded devices, home routers, these security camera DVR systems, which a lot of them are OEM'd, and they're all the same kind of underlying hardware, but just different software on top, those types of devices. So.
Yes, absolutely. So it appears that they're targeting any kind of a Linux system. In fact, there's a chance that there are some embedded devices that have this sort of capability associated with it. We haven't really researched that specific bit.
Right.
And pointing out this Synology Visitation Manager, Just repeating again, I think this is probably the third time on the program we've shared this particular slide, but there are a couple of descriptions of exploits that are associated with that are posted on the internet so that you can understand a little better about what's going on. Next item here is scan probes on port 1900 UDP. This happens to be associated with the Universal Plug-and-Play Simple Service Discovery Protocol. So the intent here is that it enables, in this particular case, Microsoft SSDP to discover universal plug-and-play devices on a network. What we're seeing is activity from a single U.S.-based IP address. There was sort of a surge in activity around the third week in February. Since then, what we've seen is sort of a surge or a resurgence of activity, but more specifically, it appears to be very automated for specific periods of time and continuing on a regular basis. It looks like about midday each day we're seeing a set of scanning activity and then it turns off. So I don't know if they're actually looking to try to scan specific address space and identify things or if they're sequencing over time. I hadn't investigated that in a whole lot of detail. And I don't know, John, do you have any other comments or thoughts about this one?
Well, I mean, the only thought I have is we're aware that this is a UDP protocol, and it has potential for amplification. So there might be scanning involved in trying to identify devices that could be used as yet another reflection type of source, similar to the NTP and DNS stuff that we've talked about. I don't know that that's what's going on here, but I know it's been mentioned in other, research papers and whatnot that this is another one of those potential UDP protocols that could be used for that.
Right. So that would be one thing that we want to be paying attention to, take a look at. One of the other things that we've always sort of raised a concern about, and it's actually probably been some time since we've talked about it, but universal plug-and-play is basically a tool that gives devices permission to poke holes through your firewall. And which is not necessarily a bad thing, but if something has the opportunity to do that with malicious intent, then it could cause a problem. So again, the notion here is that you have an internal application, presumably a trusted application, one that's on your LAN side of your network, and the universal plug-and-play is intended to give the opportunity to be able to make connections to the internet. It's used often for gaming services where you want peer-to-peer connections to be set up, but you don't want to necessarily permanently open those ports for access. And as a consequence, if you do have a malicious application that gets inside your network, perhaps a compromised computer, for example, it has the opportunity to generate backdoors. And in fact, what this could potentially be doing is looking for the opportunity to create those backdoors because of a access that's been exposed. So that's one of the things you might want to be paying attention to or considering as well. Make sure that your external gateways aren't offering this service unintentionally. The next item here, scan probes on port 21 TCP. This is associated with the file transfer protocol, a very popular protocol, particularly in the past. I think the recommended use or way of doing this today is probably through SCP or a secure copy protocol. But in any case, the majority of the probes here are from China, so this is not, although you might see a little similarity in the pattern, this does not appear to be directly related to that port 1900 scanning activity. There certainly is that same sort of daily pattern, perhaps suggesting a cron job or something along the lines of that is performing this scanning. I'm not saying it's not related, but the relationship is not obvious. That is the relationship between this port 21 activity and the port 1900 UDP activity. As I said, the majority of probes are from China. There are also some from Russia and Romania, but it's on the order of magnitude less in terms of activity. So what I expect is that this big stuff is probably, the big spikes here are probably China, and then where you see the Russia and Romania are probably these lower spikes that you see kind of more random taking place in between. And by the way, that's probably performing password guessing attacks or looking for weak passwords or perhaps some no passwords for accessing FTP.
Yeah, that's what I was going to say. There's plenty of FTP servers out there that allow anonymous authentication into them. If you do that, just make sure you don't let people write to them so they can put files there, because you could be hosting malware or all kinds of other stuff if you allow that kind of access to your FTP server.
Absolutely. Next item here is our standard pie chart, basically looking at the most probed ports. As we've already talked about, port 5000 is at the top of the list. Port 23 is next in line here. We're going to take a little bit of a closer look at that in a moment here, followed by port 22, 445, port 80, port 443, so scanning for websites, port 1433, Microsoft SQL database, port 3389, that's remote desktop protocol, and a newcomer here. I had to investigate this a little bit further. Port 1998, we'll take a little bit of a closer look at that one. This port is actually associated with Cisco XOT, which is actually X25 over TCP. So it's a tunneling protocol for something that I would describe as ancient pre-internet protocol, the X25 that is. I doubt that that's what they're looking for here, but there certainly is some scanning activity on this port. We've seen some surges of activity on second week in March and here into the third week in March. And most of the probes are coming from multiple addresses in a single U.S.-based cloud service provider. Quite frankly, I'm not sure what the motivation behind this is. There are some somewhat distinct patterns associated with it. It certainly looks like it is scanning activity with perhaps not good intentions in mind. So this is something you'll probably want to keep in mind. Again, there may be some sort of obscure application. I did find, for example, there's a call manager application that uses this port for data transfers. And so there's that slight possibility that they're looking for something like that, but there are also a number of other ports that are probably more likely to find associated with that particular application. So I didn't put it on here because it didn't look like a strong candidate. A little more searching is probably needed in this particular case, and some more investigation. Next item here, most sources doing probing, and we have our standard port 445 showing up here, and then next in line, port 23 TCP. As I said, we'll take a little closer look at that. We already talked about port 5000, port 8080 TCP, which we commonly see, and if we provided an update on the status of the zero-access P2P activity last week, if you're interested to go and take a look at near the end of the program from last week, which does show a downward trend in the number of sources and the amount of activity associated with the now defunct zero-access botnet and the P2P activity associated with those. And then last but not least here, I wanted to share with you the number of scanned probes on port 23 TCP, that's Telnet, usually looking for weak passwords again. I'm showing 90 days of activity just to give you some context on how things have changed. We always have seen scanning activity on this port, but the volume of activity has gone up significantly. What we're seeing here is around about the beginning of February, a big surge in activity up into the millions of probes per hour. It hasn't been entirely consistent. You can see that there's some activity that's, again, it looks like it's working off of a cron here, where we see a spike for each day of the week. And then we've hit a sort of a new record just recently. I think it was just yesterday. Actually, it looks like the beginning of today here, where we hit on the order of about 225 million probes in a single hour. I wouldn't get too wound up on the specific number there because we're really only looking at a portion of the network in this particular analysis. And so the actual activity is quite a bit higher than that. In fact, at that level, they probably have the capability of basically probing almost every address on the internet within the time frame, certainly a day, if not within hours or less. And with that, that's our show for today. If you'd like to get in touch with us, you can email us at threattrack@list.att.com. You can also find us on Twitter. Our handle is @ThreatTraq. The ThreatTraq video is available on the ATT Tech channel at att.com/ThreatTraq, as well as on YouTube. I should point out ThreatTraq is spelled ThreatTraq. Just let me give you a little reminder of that. An audio-only version is available on iTunes. Thank you for joining us today. Thank you, John, and we'll be back next week with a new episode. And until then, keep your network safe.